All right, today we are diving deep into a world that feels a little like science fiction, but I promise you, it's happening right now. We're talking about high-tech indoor fish farming, and more specifically, the incredible digital brain that makes the whole thing possible.
So let's just start with the biggest question right off the bat. How on earth do you raise millions of fish inside one building? I mean, this isn't your grandpa's little pond out back. We're talking about huge industrial facilities packing a mind-boggling number of animals into a very controlled space. The real challenge is, how do you manage the crazy amount of risk that comes with that? Because here's the thing, when you push for these super intensive systems, cramming more and more fish into the same amount of water, your margin for error, your safety net, shrinks down to practically zero. If something critical fails, like a pump goes down or the oxygen dips, you don't have hours to fix it. You'll literally have minutes before it turns into an absolute catastrophe. Now, the technology that makes all this possible is something called a recirculating aquaculture system, or just RAS for short. It is an absolutely incredible piece of engineering, but as you're about to see, it's a high-wire act with some very, very high stakes. So, what is a RAS? Well, you can think of it like a life support system for fish. It's a closed loop. Instead of constantly pumping in new water, it takes the same water and recycles it over and over and over, running it through this whole maze of filters to clean it up and keep the conditions perfect. It's super efficient, right? But it also means the fish are 100% dependent on that machinery working perfectly, 24/7. And you don't have to take my word for it. Listen to what aquaculture engineer Rick Jones says. He points out that you could be right there on site, just in another part of the building, a pump fails, and you might not even know it happened until it's already too late. The speed at which things can go south, it's just staggering. Okay, so if the risk is that high and the clock is ticking that fast, how do these farms even exist? How do the owners sleep at night? The answer is you build a digital nervous system. You create an automated watchman that never sleeps, never blinks, and never ever gets distracted. And that watchman is called an MCAS. It stands for Monitoring, Control, and Alarm System. It really is the brain of the whole operation. Let's break that down. Monitoring. It's got sensors everywhere, watching dozens of data points in real time. Control. It actively adjusts the equipment to keep everything perfectly balanced. And the most important part, alarm. The very second something goes wrong, it screams for help. You know, this brings up a super interesting point about the people involved. A lot of folks hear automation and think it's about replacing humans, but that's not really the goal here. The MCIS handles all the tedious, repetitive, mechanical stuff, which frees up the actual biologists and technicians to do what they do best. Focus on the fish themselves, on their health and their well-being. So what is this digital farmhand actually doing all day and all night? Well, its to-do list is absolutely massive. It covers everything from the invisible stuff, like water chemistry, all the way to the heavy lifting of moving tons of water. Okay, job number one, without a doubt, is water quality. The system is constantly checking dissolved oxygen levels and adding more when it's needed. It's using these little dosing pumps to keep the pH perfectly stable because even a tiny shift can stress out the fish. It's even controlling fans to manage CO2 levels and keeping the salinity just right in saltwater setups. It's a chemist and a life support specialist rolled into one. And it's not just the chemistry, it's the physics too. It's watching water levels in tanks to make sure pumps don't run dry. It's controlling the speed of those pumps to get the flow just right. It even runs the lighting schedules and automates these super complex feeding plans. And here's the really brilliant part. It can actually detect when a motor is starting to fail before it breaks, preventing a crisis from ever happening. Now, this amazing level of control didn't just appear overnight. The technology has gone through a huge evolution. I mean, we've come a long, long way from a simple buzzer and a flashing red light to these incredibly smart cloud-based systems that give operators powers they could have only dreamed of a decade ago. You can kind of think of it in 3 levels. Level 1, the most basic, is a discrete controller. That's just one sensor doing one job, like monitoring pH. Level 2 is a package system, a little smarter, maybe managing a handful of sensors for a single tank. But the top tier, the absolute state-of-the-art, is a full industrial SCADA system. That's when every single pump, sensor, and feeder in the entire facility is connected into one big, intelligent network. And this change has completely revolutionized the life of a farm operator. Think about it, the old way. A pager goes off at 2 in the morning. You have no idea what's wrong. You just have to race to the farm and start looking for the problem in the dark. The new way? You get a specific text on your phone, you pull up a dashboard on your tablet, see exactly what's going on, and sometimes you can even fix it right there from your living room. It's a total game changer. So the tech is obviously impressive, but what's the real payoff? What's the bottom line? Well, it all comes down to making these massive, multi-million-dollar facilities safer, smarter, and a whole lot more efficient.
The single biggest benefit, hands down, is protecting that huge financial investment. An MCAS is basically the ultimate insurance policy against that catastrophic failure we keep talking about. But it's not just about playing defense. It also drives massive gains in efficiency. And by keeping the environment perfect, it directly improves the health of the fish.
And these aren't just vague improvements. We're talking about real, tangible savings. For example, instead of running a giant pump at full blast all the time, the system can slow it down when demand is low, saving a ton of energy. It injects only the exact amount of oxygen needed, so none is wasted, and it lets your most skilled workers, your most valuable resource, focus on the animals instead of just checking gauges all day.
And believe it or not, the technology is only getting smarter. What we have today is amazing with cloud dashboards and remote control, but the systems of tomorrow are all about artificial intelligence. We're talking about AI that can analyze all this data, spot trends a human would miss, and make predictive adjustments before a problem even starts. Just imagine real-time sensors that tell an AI exactly how much the fish in a tank weigh, so it can adjust their feeding down to the single pellet.
So all of this incredible automation and intelligence, it all leads to one big fascinating question. We've seen the role of the farmer shift from manual laborer to high-tech systems manager. As these systems get even smarter, even more autonomous, how much is left for the human to do? It makes you wonder, will the farms of the future need farmers at all? Or maybe the future isn't about getting rid of the farmer, but completely redefining what that word even means.